All right, so what I want to do is just somewhere in your book, maybe off to the side, I'm going to draw a couple things. So today we're going to talk about non-proportional versus proportional. So in module 3, we talked about proportional relationships. And I want to talk about a couple of things. Proportional relationships, when you graph them, they always go through the origin. So when you have a proportional relationship, they always cross through where the x and y axis cross. Okay. So they always contain the point 0, 0, and that's called the origin. And in case you're a little rusty, this is the x-axis, this is the y-axis. And then they always have what we call a constant slope. Remember that the constant slope, if I go from one point on the line to the next point on the line, I go up and then I go over. This is called the rise and this part here, what's that called? The run. So remember that the equation looks like this. Y equals K times X. K is called the constant of proportionality. But it's also the slope. And lastly, the slope is the rise over run. Okay, it's the rise over run. I'll leave that up there for a second for you guys to write that down. Hello. Sure. Bye. Finish recording. So that, just to kind of summarize, proportional relationships, we have a straight line, which, by the way, we haven't really talked about a whole lot, but when it is a straight line, we call that linear. Linear, it literally has the word line in it. So anytime we have a graph that has a straight line, right, we call that linear. And it goes through the origin. Well, there are some linear relationships that are non-proportional. So over here to the side, put non-proportional. And I'm just going to abbreviate it. Non-proportional relationships are still linear, but they're written in the form of y equals mx plus b. M is still the slope, but what's b? Does anybody know? That's referred to as the y-intercept. And we'll unpack this quite a bit as we jump into this next one. But basically, for this graph, the nonlinear, it's still a straight line, but it crosses the y-axis somewhere other than the origin. So this point right here is going to be 0, whatever the b value is of the equation. You still have the slope. It's still a straight line. It just doesn't cross through the origin. Now, the reason for that is that b is also the y-intercept, but usually in a real-world scenario, it is what we call the initial value. Mr. Adams starts off with $5, puts it in a checking account, and then I add $2 every week. What's the initial amount I put in? $5. How much does it grow by every week? $2. And then I make an equation that I could plug in how many weeks I'm going to put money in my account, and that equation will tell me how long I need to put money in my account to get $200 or whatever the case is. Now, I wanted to preface that because that's what we're going to do in our example. Can I move to the example? Do you guys have this written down? All right. So it says you can use an equation to describe the relationship between two quantities in a real-world scenario. You could use a table of values that make an equation true. So to make an equation true, we're going to do a little bit of math. Does everybody have a calculator? If you don't, can I get a couple people to pass those out? Because we're going to let our calculators do a little bit of work for us today, because we gotta repeat a lot of work. All right, here we go. So it gives us the equation 3x plus 2 is the total charge, where y is one person to rent a pair of shoes and bowl X number of games at Baxter's bowling lanes based on the prices shown. So what we want to do is we want to complete this chart. So this chart, in order to complete it, we need to think of like how many games you're going to bowl. Well, you might bowl one game, you might bowl 2 games. What do you think I could put in here? 3. What about here? 4. Now, really what I'm going to do is I'm going to plug that into my calculator and figure out what that is. So if I plug in or substitute 1, I get 3 times 1 plus 2. 3 times 1 is 3 plus 2 equals 5. Now, if I do the same thing for 2, I'm going to write this over here. I'm kind of running out of space. If I say y equals 3 times 2 plus 2, what am I doing? Wherever there's an x, I'm plugging in this number. And then I'm multiplying by 3 first, and then I'm adding 2 to it. What's 3 times 2? What's 6 plus 2? 8. Now, if I plug in a 3 here, somewhere over here, I'm going to have to find some space. I'm going to say 3 times 3 plus 2. What's 3 times 3? 9. Plus 2 is 11. Now, over here, there's a pattern. What am I adding to 5 to get to 8? What am I adding to 8 to get to 11? What do you think I'm going to do here? We think it's 14. How can I double check that? Yeah, I'm going to plug it in. So I'm going to say 3 times x, which is 4, plus 2. What's 3 times 4? Plus 2. 12 plus 2 is?
Oh, I thought we were adding 3.
No.
My bad.
Yeah. So this is equal to 14. And that is basically it on that. Now, the reason I had you guys grab your graphing calculator is we want to do this. Oh, that's not cooperating today. There we go. So we have this equation, y is equal to 3x plus 2. And so we're going to represent this a couple different ways. The first way, and we've been doing it this way, but I want to be a little more formal in my instruction. When we say x comma y like this is known as a table of values. And so when I plug in 0, right? Well, let me do this a little differently. So if I say y is equal to 3 times 0 plus 2, 3 times 0 is 0, 0 plus 2 is 2. And then on the previous page, we said that 1, 2, 3, and 4 are going to be 5, 8, 11, and 14. Now, there's some other stuff I want to talk to you guys about. To go from 0 to 1, what did I do? I added 1. To go from 1 to 2, what did I do? I added 1. To go from 2 to 3, what did I do? Add 1. To go from 3 to 4, what did I do? This is known as delta x, which is also my run, which is equal to 1. Now over here, to go from 2 to 5, what did I do? Add 3. To go from 5 to 8, what did I do? Add 3. What am I doing every time? What do you think we call this? Delta y. It's the change in y, which is also known as what? Rise. Also, we said that the slope is equal to the rise over the run, right? Well, isn't that the same as y sub 2 minus y sub 1? Yep. And the run is the same as x sub 2 minus x sub 1. So when we say we're adding 3, what we're really doing is we're saying, what is 5 minus 2? 3. What is 14 minus 11? 3. What is 11 minus 8? 3. So that's this stuff right here. And then we do the same thing with the x. What's 4 minus 3? 1. What's 3 minus 2? 1. So my slope then is equal to my rise, which is positive 3 over 1, or 3. Hey, isn't that this right here? Now I said, what is this? I said that this is the y-intercept. That's where it crosses the y-axis. Crosses y-axis. That's what the y-intercept does. It intercepts the y-axis. And you're like, Mr. Adams, I think we're done with this problem. No, we're only beginning. Well, notice that that occurs when x equals 0. Now, if I plot all these points, the points on the graph are 0, 2, right? Because we're going to say x, y, and 1, 5, and 2, 8, and 3, 11, and 4, 14. Okay, that's a lot of work. Turn on your handy dandy calculator. Why isn't there? It goes. Now we're going to do some fancy math here. Hit the y equals button. Yes. Yeah. No. No. You can't. No, just stick to this formula. So the question is, Mr. Adams, on the slope formula, can we, instead of doing y sub 2 minus y sub 1, can you do y sub 1 minus y sub 2? I'm just going to say no. Always do y sub 2 minus y sub 1. X sub 2 minus x sub 1. What's going to happen is somebody's going to get confused and get the 1s and the 2s backwards on one of them, and you'll get the wrong answer. Okay? But now watch this. Hit y equals on your calculator. Turn your calculator on, hit y equals. And then just go over here. There's probably some stuff plugged in there from my other math class. Highlight where you're supposed to plug in the equation and hit clear. Okay. Is everybody on this screen? All right. Is there anybody having issues getting to this screen? Just going to hit the y equals button. Now type in 3. This is the x button right here. You see this button here? X plus 2. The X button is the second column, third button down. It's right here. Look at the screen. This is the X button. It says XT, theta, and this button right here. Okay. We use X so much on these graphing calculators that they made a button for it. You could get it with the green letters, and that's okay too, but I just like using this button. Okay. Now what I want you to do is go to Zoom, and Zoom Standard, the Zoom button is highlighted in red. Zoom Standard, which is option number 6, that's the one that we want. That shows the window. It zooms in on the graph from -10 to +10 in the X direction, from -10 to +10 in the Y direction. Now hit graph. Whoops. I didn't do the Zoom Standard. Now you'll get it. So this is our graph. So let's look at a couple of things. Go ahead and hit the trace button. Does everybody have the graph? Is there anybody that does not? Sometimes the calculators, the kids from the previous classes mess with them and put stuff on there. So if you have an issue, let's figure it out now. Yes. I can't see that from here. Do you need help or you have it? You got it? Okay. So anyways, hit the trace button. That's this button right here. Now, if I plug in an X value, it will automatically take me to the corresponding Y value. In other words, notice that when X equals 0, what does Y equal? 2. Let's plug in 1. So just hit the button 1 and it'll say X equals 1. Do you have this on your screen? Hit enter. So when you're in trace mode, by the way, it's 1, 5, right? So this is our graph. I'm going to take a little screenshot of that and put it in our notes. So when I graph this, this is what it looks like. And then lastly, on your graphing calculator, we're going to do one more thing. See over here where it says table? See the button that says graph? See how it says table in blue? Yeah. Anytime we want to access something that's written in blue, you hit the blue button, which is second. So it's like a shift key. You know how you like hit shift to get a special character above the 1, 2, 3, and 4 on your keyboard? That's kind of what we're doing here. So hit second graph. And then scroll down till you get to 0 or up, depending on where you are on your calculator. And I'm going to take a little screenshot of that. So what this is my table of values as it's calculated by the calculator. So I'm going to ask you guys a couple questions. When X equals 6, what does Y equal? 20. When X equals 4, what does Y equal? Do you guys see how that works? These are all points on the graph. Okay? There any questions? Now, what's nice about this, you guys know how to add, multiply, and divide, and subtract. But sometimes we're going to need to do this a lot, right? We can all multiply something by 3 and then add 2 to it. But we're going to have to do this a lot to graph it. So I like to just use the graphing calculator. So this scenario, by the way, what does X represent? Does anybody remember? Read the problem in your book real quick. What does X represent? Yep. X represents the number of games. Bowling games, right? Number of games. And what does Y represent? Total cost or charge. Well, what does the book say? Charge or cost? Charge. So the total charge. So if Mr. Adams goes and I say, how many students are in this class? 25? And I say, all right, guys, I'm going to take you guys and we're going to go bowling. Yeah, sweet. And I gotta submit a report to the principal as to how much this is going to cost. Can I figure out how many games do you guys want to play? No, be realistic. We'll say 3. We'll say 3, right? So 3 games per student. I have 25 students. How many games is that total? 75. Can I figure that out real quick? Of course I can. Only thing I gotta do is keep scrolling down here till I get to 75. I could plug it in the calculator, probably be quicker, but I just want to show you this way. Get you familiar with the calculator. So if I were to take all of you bowling, how much would it cost the school? $227 just for the games. And that includes the $2 for the shoe rental. All right? Well, actually, it'd be a little bit different. Actually, it'd be it'd be a little different. That's if I played 75 games. But you get the point, right? Okay. So sometimes the equation is easier. Technically, I think to answer that question, how would I do that if there's a $2 shoe rental per person? I'd be better off finding out what the cost is, $3 per person, which is $11, or 3 games per person, which is $11, and then I go on my calculator and I multiply 11 times 25. So it actually costs $275. Okay. All right. That's it for that one. Does anybody have any questions?